How's everyone doing? Awesome, great to be here. Thank you, Bright Data team, for having me here. It's a great honor to talk at this first Web Discovery Summit. And the topic that I'm going to be talking about is a nugget that Orr dropped in his presentation, which is that data has a decay problem. I use the term half-life crisis, right? So we talked about bar mitzvah, and now we're talking about midlife and half-life crisis of data. So we're growing up really fast. No, I think this is an existential problem that we are facing as an industry, primarily because we as humans have gotten really good at creating data. And you've seen all the stats out there. Every 2.5 years, we're doubling the data. It is getting out of control. We are creating so much data exhaust that it's becoming irrelevant and it is decaying at an unprecedented rate. Second, we are having a generational shift in terms of our collective attention span, right? So we're all experiencing that. What it means is we saw the decay curves that Orr was showing. When you look at social media, the decay happens, the half-life is literally few minutes, or at best, it's a handful of hours, right? Even for non-social media assets, it is a handful of days, after which the data is pretty worthless. So the combination of those two things is precipitating a crisis that we call as the data half-life crisis. Now, traditional approaches of using things like static web searches and having humans crawl through that and stuff like that is simply not going to work. But there is a new approach that is emerging with companies like Bright Data, with live web data feeds, and with agentic AI applications. We have now the opportunity to take the problem out of human hands and put it in the hands of agentic applications to help solve this in a very, very different way. So that's what I'm going to be talking about. So when you look at the 1-2 punch that I was just describing, where you have live web data feeding agentic applications, that all starts from establishing data relevance. So data relevance has two important ingredients. One is this data, to be relevant, needs to be fresh. And it is as simple as what it sounds. Fresh data means that you have to keep up the frequency of how quickly you're refreshing your data feed. And the second one that is really, really important is that you need to do this fast. You need to do this with low latency. You need to do this at a very global scale, like what Orr was talking about. This is truly a global scale operation, right? So when you have these two things, when you have fresh and relevant, fresh data delivered at a very low latency, you now have data relevancy, and now you can start changing the paradigm from frozen, stale search indexes into a new world which is really embedding this live data into applications powered by AI. So that's what AI is going to help us solve going into the future. And by democratizing the access of live data from a very specific centralized web search engines and putting it into the hands of millions of specialized engines that are really embedded inside everyday applications, we're changing the game, right? We're changing the game by going from a very centralized, old-school web search experience, and we are democratizing that by building search engines into every application imaginable. So you may be a little puzzled. So let me land this with a concrete example. One of the most complex data feeds that you can imagine, especially from a data staleness perspective, is travel data, right? So travel data is notoriously tricky because of a number of factors. Number one, travel data, if you think about flight status, it's changing on a minute-by-minute basis. Travel fares, airport information and things like that, accommodation information, accommodation fares. All of these things are incredibly fast-paced. So you have that on one hand. On the other hand, all of these systems actually reside in really old-school 70s technology, like mainframes, AS400, Sabre. Anyone has used Sabre? It is not for the faint of heart, right? So building a B2B or a B2C travel application is a very, very significant undertaking. It takes years, it takes hundreds of developers to build and monitor and operate. So imagine a world where we can actually build it in a very democratized fashion using natural language processing, using data from a platform like Bright Data. So that's literally what we have done in the last 24 hours. We quickly whipped up a demo to show you, to underline what it means to take the concept of web search from the human hands and put it into agentic terms. So let me show you a quick demo of the art of the possible so that you can get into the right frame of mind for the rest of the conference.
Let's see how we can use Bright Data to get real-time information for a travel agent built with DigitalOcean's agent platform. This agent will speak with you to understand your travel needs and then use real-time information to plan and book your travel. It will make a variety of judgment calls across various decision axes like pricing, your schedule, and your preferences to completely handle travel logistics tailored just for you. So how does the agent stay up to date with rapidly changing travel data? This is where Bright Data's SERP API comes in. It lets our agent get structured information on flights with a simple natural language query. This is the crucial part. It gives our agent unrestricted access to fresh data. We don't have to hope that an airline provides a clunky, limited API. The agent can get the data semantically. It just asks for what it wants, and Bright Data delivers. We encapsulate this functionality in a DigitalOcean function, which is a serverless way to run snippets of code. I've formulated this Python function that calls the Bright Data API and returns structured flight information, a list of flights with their flight times, costs, airplane lines, and more. Once we add our environment variables, this function's ready to run. Let's take a look at the output when I ask for flights from Boston to Atlanta, leaving November 3rd and returning on November 10th. We can see some details about the request, along with several different flight options. Each flight includes information like the price and the total travel time. Now that we have our function, we can use DigitalOcean's Agent Builder to create an AI agent that can use this tool to help us plan our trips. Let's go to the agent platform and create a new agent. First, we give the agent a name, and then we give it agent instructions in order to guide its overall behavior. Next, we select a model to be the brains of the agent. We'll use the open source GPT model. I'll add the agent to the Travel Assistant workspace. Workspaces allow us to group specialized, related agents together so they can offload work to each other. In this example, our travel agent is the only agent that will be in this workspace. And finally, we can add knowledge bases. But in this case, we don't need any. Rather than uploading a pile of static documents to a fixed knowledge base, our agent will leverage Bright Data to effectively turn the internet into its knowledge base. The agent will get everything it needs live and in real time. This is a much more powerful way to build. So we can just go ahead and create the agent. Now that our agent has been created, we can add that serverless function as a resource for it to use. We name the function and then provide a description of it so the agent knows when to call it. Next, we add the input schema, which lets the agent know what information it has to pass in order to use this function. In this case, we just have one parameter called query, which is the natural language search query for the flight. And finally, we add the output schema, so the agent knows what type of information it can expect to receive from this function. After we add the function, we can see it available as a tool for the agent to use. We'll add a few more functions so the agent can also fetch and book hotel information and interact with the user's calendar. Once these are added, we can hook up our travel agent to a UI and let it get to work. We want to fly to New York on November 15th and return on the 19th if possible. The agent knows we're flying out of San Francisco because it has access to the user's profile and calendar. The agent asks a clarifying question, using its general knowledge to understand that travel requirements change depending on the type of travel. Once answered, it has everything it needs. It checks for available flights and hotels, sees what works with the user's calendar, and then formulates a travel plan and asks for confirmation to book. It knows the user's schedule and determines the best plan for the user. For example, the agent knows that coming back on the 19th isn't a necessity, and since there's an important board meeting that day, it books a flight for the day before. It selects different airports for the best time flights, and then it plans to book at the usual hotel that the user stays at. The agent asks for confirmation and specifies the credit card it will use to book everything. After a slight adjustment from the user, the agent modifies the itinerary, books the flights and hotel, adds the events to his calendar, and emails a summary to the user. By plugging Bright Data's SERP API directly into the DigitalOcean agent, we gave it a real-time connection to the world. It can react to price changes, find last-minute deals, and navigate the web's complexity just as a human would, without relying on other organizations' willingness or ability to provide API access to their services.
Great. So hopefully that gave you a glimpse into what an orchestrated agentic framework can do when it is fed with live data as a knowledge base from a web platform like Bright Data. So what is remarkable about this is live Bright Data running on the DigitalOcean platform that was feeding all the information. So think of this as Bright Data is the eyes and ears of this system. In this case, it was the open source GPT version that was the brains of the operation, doing the NLP and things like that. And an agentic platform like DigitalOcean was the arms and legs, actually doing the work and running around and orchestrating things. So this is how the future is going to look like, where we take the onus from human search and put it in the hands of agentic platforms, powered by live data feeds from a web data platform like Bright Data. So this is an actual footprint of Bright Data running on the DigitalOcean platform. I don't want to go into the details, but as you can see, this is like real world scale. And Bright Data has been scaling up on DigitalOcean using a variety of different technologies. And bringing the whole thing a full circle, I want to leave you with this. So solving the half-life crisis of data really starts with data relevancy. Establishing data relevancy is the fundamental tenet of solving this problem. And you do that by having freshness of data. And I think you're going to hear this over and over again for the rest of the day, but doing this in a scalable way, doing this in a way that understands the freshness quotient that Orr was showing, doing it in a way that can be live fed into agentic experiences and let them run with data in a live fashion. I think that's going to be the key thing. The second one, obviously, is doing it with incredibly low latency and at global scale. With the combination of these things, what we are doing is we are democratizing web search from just being in a monolith, and we are breaking it into curated experiences that can be embedded into every application. So that is a really, really powerful thing if you think about it. That's what the democratization is going to look like. So with that, I hope this got your creative juices flowing in terms of the art of the possible for the rest of the sessions. Again, thanks to Bright Data team for having us and give you a glimpse of what is really possible with the powerful combination of all these technologies that are emerging. So thank you, and have a good rest of the conference.